is example number 2, and this is related to bijective function. So the problem says that show that the function f from R to R defined by fx equals to x cube plus x is bijective. How to show it? So bijective means you have to show that f is injective and f is surjective. Now injectivity part, let fx equals to fy implies that x cube plus x equal to y cube plus y, implies that x cube minus y cube plus x minus y equal to 0, obviously. So now what is the formula? X cube minus y cube means x minus y into x square plus xy plus y square plus x minus y, that is equal to 0. So now the common part is x minus y, so x minus y common. So x square plus xy plus y square plus 1 equal to 0. So either this equal to 0 or that equal to 0. That's why either x minus y equal to 0 or x square plus xy plus y square plus 1 equal to 0. But we can now prove that this part cannot be equal to 0. How to show it? But for all xy belongs to R, we have x square plus xy plus y square plus 1. So now write x square here. Instead of xy, we can write 2 into x into y by 2. So this 2 cancel out. So xy, that's xy can be written in the form 2 into x into y by 2 plus what is your b portion? B 2ab. So what is your b? Y by 2. So b square means y by 2 whole square means y square by 4. And there is the adjustment, plus y square by 4 minus y square by 4. And this is your plus 1 and this is your y square. Is it absolutely clear? So now from that first 3, we can write x plus y by 2 whole square, and this one plus 1, here is plus 1, and that minus y square by 4 plus y square implies 3y square. It becomes 3y square by 4. It is absolutely clear. So now got it. Since xy are real number, belong to R means real number. So this one cannot be negative, and that one also cannot be negative. It becomes 0 also, I think. If xy are 0, then this portion is 0 and that portion is 0. Otherwise it is positive. So plus 1 means, so this part should be greater than equal to 1. Got it? Other than that value, that means 0, this value should be positive and that value should be positive, and that portion is obviously greater than 1. So that 2 implies, together implies x square plus xy plus y square plus 1 is greater than equal to 1 for all xy, for any xy. So that cannot be equal to 0. So I write it. So x square plus xy plus y square plus 1 not equal to 0. That's why I reject this portion. So what is your conclusion? X minus y equal to 0. This means x equal to y. So now what you consider? Let fx equal to y. You have to show x equal to y. This shows that f is injective function. Sure. So now for the subjective part, let y belong to what? This is the procedure. Then fx equal to y. So x cube plus x plus y, and that is x cube plus x minus y equal to 0. And that equation number 1 is the cubic equation, obviously. And we know that any cubic equation has at least one real root. In your cubic equation, there are how many roots are there? 3 roots. In that 3 roots, the 3 all are equal, all are real. Otherwise, 2 complex and 1 real, because complex roots occurs in conjugate pair. That's why 2 complex, 1 real. So there is the 2 possibilities. That means number 1 possibility is all the 3 roots are real, and second possibility is 2 complex, 1 real. So the minimum possibility is 1 real root. That's why I write it. Equation 1 is a cubic equation in x and has at least 1 real root. And that root say x equal to a. Got it? That means x, instead of x equal to a, if you put there, then this equation also satisfied. So that's why I write it such that a cube plus a minus y equal to 0. This means what? A cube plus a equal to y, and since fx equal to x cube plus x, so a cube plus a means fa. So thus what is your conclusion? Thus for all y belong to R bracket codomain, there exists a belong to R domain such that fa equal to y holds, and this means the surjective. Hence f is a surjective function and hence f is a bijective function. Is that clear? Absolutely. So now problem example number 3. Let a equal to -1, 1, -2, 2 and b equal to 3, 4, 5, 6, and let f from a to b be the mapping defined by f equal to 1, 6, -1, 4, 2, 3, -2, 5. Prove that f is a bijective mapping. How to prove it? This is good sum, very good sum. How to solve it? Look at that. First element is the domain and second element is the range. We know that from class 11. So we see that what is your 1 maps to 6 by f, that means f1 equal to 6. -1 maps to 4 by f, that's why my f minus 1 equal to 4. Similarly f2 equal to 3 and similarly my f minus 2 equal to 5. Is it clear? So thus what is your range? Range is what? 3, 4, 5, 6. So thus the range of the set f is 3, 4, 5, 6. And now what is your function? Function f from a to b. What is your function? F from a to b. So a is your domain and b is your codomain. So what is your codomain here? B means 3, 4, 5, 6. And what is your range here? 3, 4, 5, 6. And that two are equal. That's why range of f equal to 3, 4, 5, 6 equal to b equal to codomain of f. And that's why it is a surjective function. Clear? First of all, this problem I have to first show that the function is surjective. Now for the injective part. So look at that. All elements, look at that. All the other elements, all the different elements of the domain maps to different element in the codomain. 1 maps to 6, -1 maps to 4, 2 maps to 3, -2 maps to 5. So all elements of the domain have different images in the codomain. That's why it is an injective function. That's why also we see that the different elements of A has different images in B. So f is an injective function and hence f is a bijective function. Clear? So now example number 4. Show that the function f from R to R defined by fx equal to ax plus b for all x belongs to R, ab belong to R is bijective. How to show it? Let's see. Let fx equals to fy. Ax plus b equal to ay plus b, a cancel out. Why? Obviously a not equal to 0, that's why it did a cancel out. That's why x equal to y and hence by injective. So now the surjective part. Let y belongs to R codomain, then fx equal to y. So ax plus b equal to y, so x equal to y minus b by a, and that should be belongs to R y because y belong to R and ab belong to R according by the question. So x belong to R and that R should be the domain. So thus for all y belong to R codomain, there exists x belongs to R domain such that fx equals to, what is the value of x? Y minus b by a. So according to the definition, x plus b, fx equal to x plus b, so a into y minus b by a plus b. That means a cancel out, so y minus b plus b, so y. So fx equal to y holds, and this shows that it is surjective function and hence it is a bijective function.